Okay, that's recording. Right, so last lecture we said that syrups with a concentration of 85% sugar are going to be self-preserving. However, it's really rare to see a syrup with that high of a sugar concentration. In fact, glucose isn't often used in syrups anymore. Preservatives are added to syrups along with the sweetening agent in order to achieve the preserving effect. Theoretically, if we had a 10% syrup and a 60% syrup, the 10% syrup would contain more preservatives. So how do we know how much preservative to add? 85% sugar concentration is seen more as a benchmark. So we're going to take the 60% sugar concentration and figure out how much preservative we need to add for the preserving effect to be equal to that of the 85% syrup. And then same with the 10%. Some syrups do contain alcohol, and if they do, it's going to be up to 10%. Elixirs are clear, pleasantly flavored, sweetened, hydroalcoholic liquids intended for oral uses. Hydroalcoholic means that the liquid contains both water and ethanol. The alcohol content ranges from around 5 to 40%, and compared to syrups, elixirs are going to be less sweet and less viscous. Because of an elixir's alcohol content, they tend to evaporate faster, so they need to be stored somewhere with minimal light in an airtight concealer. Also, children and old people usually cannot consume elixirs because of the alcohol content. So we add alcohol to liquid formulations such as elixirs because alcohol acts as a preservative, and it also helps ingredients with poor solubility in water become more soluble. At 50% concentration, alcohol is a preservative for solutions with an acidic pH, and at neutral or basic pHs, we would require an alcohol concentration of at least 18%. Alcohol is semipolar, meaning that it has both the hydroxyl OH group in order to hydrogen bond with water, and then it also contains carbons that are able to bond with the poorly water soluble drugs. In this way, alcohol acts as a co-solvent along with water. Tinctures are alcoholic or hydroalcoholic solutions prepared from vegetable or chemical substances with an alcohol content range of 15 to 80%. So tinctures made from chemical substances are made by using the simple solution method. For example, dissolving iodine into 80% alcohol would give you a tincture. Tinctures made from vegetable substances are made by percolation. This is where you take a tube containing a filter at the bottom, and then you take a crude vegetable extract inside the tube, and then we're going to pass a solvent such as 80% alcohol through that tube. The liquid that passes through the filter of the tube is going to be the tincture solution. Tinctures are rarely used, and if they are used, they're going to be used in topical applications. Also, non-potent tinctures have a higher percentage of drug per 100 milliliters of solution, and vice versa. Belladonna is also known as atropine, and this is something that can be used to dilate the pupils during an eye exam. Extracts are concentrated preparations of vegetable or animal drugs obtained by percolation. They are made in the same way that tinctures are made, except instead of using alcohol, we're going to be using water instead. So we're going to take a tube with a filter and a crude vegetable or animal extract, and then instead of passing alcohol through it, we're going to pass water through this tube, and then the solution that comes out of the filter will be the fluid extract. Spirits are alcoholic or hydroalcoholic solutions of volatile substances, such as volatile oil, which with an alcohol concentration range of 62 to 85%, Of course, we wouldn't give a patient a drug with an alcohol content of 85%, so spirits are mostly used as flavoring agents and they are alcoholic based. Aromatic waters are like spirits, except they're going to be made out of the volatile oil plus water instead of alcohol. Topical solutions are used on the skin. Local anesthetics are an example of a solution spray. So hydrogen peroxide, chlorhexidine, providone, and thimerosal are going to be examples of antiseptic, antibacterial, topical solutions. Otic solutions can be used to treat ear infections, pain, and earwax buildup. Otic solutions do not have to be sterile, but they should be isotonic. But they should preferably be oil-based, and so we're going to be using glycerin or propylene glycol. Ophthalmic solutions must be sterile and preferably isotonic, meaning that the concentration of sodium chloride in solution should be around 0.9%. This is the same tonicity as the eye fluid. They are also going to be buffered to have a pH close to that of the body, so around 7.4, and this is going to prevent corneal damage. Ophthalmic solutions also need preservatives since solutions like eye drops will most likely be used multiple times, and those preservatives include the cresol or phenol. Ketorolac ophthalmic solution is an NSAID, meaning it treats inflammation. One of the inactive ingredients over here is sodium chloride, and this is going to aid in making the solution isotonic. Another inactive ingredient is the hydrochloric acid, and this is going to be used as a buffer, meaning it's going to adjust the pH of the solution. Nasal solutions can be prepared as drops or sprays. They do not have to be sterile, but they should be isotonic, and this is to avoid damaging the cilia inside the nose. So when the cilia is damaged, it ceases its natural movements. Nasal solutions can also produce local or systemic actions, which just means the overall action within the body. And this is because there's a large amount of blood supply in the nose region which will absorb the drug quickly. For example, people snort cocaine, and this isn't because it makes the nose feel good, but it's because they want that systemic effect throughout their body. So another example of a nasal solution would be this desmopressin. Injections must be sterile and should be isotonic. For injections with large volumes, they definitely must be isotonic. But for single shot injections with small volumes, they don't necessarily have to be isotonic because they will eventually get diluted in the body anyways. And injections are also going to be pyrogen free, meaning that they do not contain anything that may cause a fever. When choosing a solvent, it should be stable, be able to dissolve the inactive and active ingredients, and the body should be able to absorb it. So water is the preferred solvent. Tap water is never acceptable because it has a significant amount of other solids, such as salts, metals, and fluoride in it, estimating about 100 milligrams of impurities per 100 milliliters of fluid. So we use distilled water instead because it has about 1 milligram of impurities per 100 milliliters of water. So basically, distilled water is going to be 100 times more pure than tap water. We also use distilled water for oral solutions, but not for injectables because injectables have to be pyrogen free. Co-solvents enhance the solubility of poorly water-soluble drugs. For examples, alcohol, propylene glycol, and glycerin. For OTC products, there are alcohol content limits for certain age groups. It's going to be 0.5% for children under 6 years, 5% for children 6 to 12 years in age, and 10% for children and adults over the age of 12. So types of alcohol. Ethyl alcohol is going to be 95 to 96% alcohol. Dehydrated alcohol is 99.5% alcohol and is used when water-free alcohol is needed. Diluted alcohol is 50% alcohol and 50% water, and then those three alcohols are going to be used in oral solutions. So ethyl alcohol, dehydrated, and diluted alcohol will be used for oral solutions. Rubbing alcohol and isopropyl alcohol are very similar in terms of uses, usually topical, but rubbing alcohol is ethanol. Isopropyl alcohol cannot be broken down by the body, so it's going to be lethal when consumed in large quantities. Technically, you can consume rubbing alcohol, but you really shouldn't do that either, which is why they contain bitter agents such as the sucrose oxaloacetate, so that people don't consume it. Glycerin is also a co-solvent. It is sweet and can be used as a preservative. Glycerin is also very viscous, so heat may be required to dissolve compounds in it. Also, unlike syrups, which can eventually crystallize the sugars in it, glycerin prevents the crystallization of sugars. Alright, looks like I'm done for today. See you guys next time.